All right, so we're going to talk about double rotation for AVL tree now, which is an additional way of bringing AVL tree back into balance. So let's look at another case of unbalanced binary search tree. And the question is, can we fix it like we did before by doing a simple rotation? Well, if you try that, here's what you're going to end up with. You are going to just kind of just rotate this whole thing by to the right by 90 degrees, and you're going to end up with a 1 at the top. You're going to end up with a 3 as the right child, which is fine, but then you're going to end up with a 2 as the left child, but that's bad because 2 is greater than 1, so it should not be in the left subtree of 1. So this is not a BST anymore, and that's not the right way to keep things in balance, right? Because remember, the order in a BST is very, very important. That's what makes a BST a BST. Anyway, so the way to actually do this is it's going to take two rotations. So we are going to do first rotation, and we, instead of rotating to the right, we're going to be rotating to the left. Okay, we're going to bring 2 up, and then 1 is going to become the left child of 2, and that's okay because 1 is less than 2, so it's on the left hand side. Now, once we are in this case, then there's something that we have seen before and we know how to fix, right? By doing a single rotation to the right. So this is exactly the same thing before, but we must do the rotation to the left first before we can do this. Now, some literature refer this to as the left-right case because the node that violates the invariant, and you travel down left first and then to the right. That's the subtree that's too high. So this is the left-right case. Okay, so here is, it looks almost exactly like what we had before, but it's the mirror image. So give this a try, see if you can bring this tree back into balance. And here's how we do it. So we will, in this case, we will rotate to the right first, right? Bring 2 up, and then put 3 as the right child of 2, and then we rotate the other way at the top, and we kind of just put bring 2 up to the top, and then 1 as the left child of 2. So this is, as you kind of guess it, this is the right and then left case. So there are just these two types of double rotations. Okay, here's a little exercise for you, slightly more complicated in a slightly bigger tree. This is the original tree without the dash line, without the number 12 in it. And if we insert 12, if we insert 12, insert 12 would cause this AVL tree to become no longer an AVL tree. It's no longer balanced. So how do you fix that? And here's how you fix it. So this is the, if you have to have a name, this is going to be the left or right case. But if you recognize this shape, then the first thing is at the lower edge here, you do a left rotation, and then we get this. We bring up the bottom, number 12 up here, and then 11 is below 12. And then we do a right rotation in the top connection. So we bring up the node 12 to be the root of the subtree, and we put 14 below it, and we keep the 12 connection with 11. So again, just notice we are preserving the data, we're preserving the ordering, and Now it's just more balanced.